All right, this is your thermochemistry lab write-up instruction video. You had two labs. One was the metal slug lab where you determine the heat capacity of an unknown. Okay, and the other lab was a heat of enthalpy lab regarding the combustion of paraffin. Okay, so now with the first lab, the metal slug lab, you're not going to have a full lab write-up. Okay, I do want graph paper. Okay, and the reason why I want graph paper is because you're going to do a graph, and that graph was described in the previous video. So on your paper, I'm going to want a graph. I'm going to want the calculations that you did in order to get the data for your graph, okay, which you would use the equation, let's see, C of the metal is equal to mass of the water times the specific heat capacity of the water times the change in temperature of the water divided by the mass of the metal times the change in temperature of the metal. Okay, this equation is what you're going to do in order to get the specific heat capacity of your 5 different metals that you did. Okay, the first one was copper. The second one was iron. The third one was brass. And the fourth was aluminum. Okay. Now, remember, in your graph, you're needing to plot on the y-axis, okay, the calculated specific heat capacity. Pretty much using this formula right here, you're going to do it for for your 1, 2, 3, 4, 5 metal samples. Okay. Now for your 4 knowns, you also have the known values for their heat capacity, and they will be graphed on this with the actual heat capacity on the x-axis. Okay, meaning if, for example, your calculation here, if I was to go, these values are these on the scale are not what you would normally have. Okay, so let's go ahead and say this is 0 and this is 0. I don't know, 0.5. Okay, and then on the actual we have 0 and then 0.5. Okay, again, like I said, these are not your values to scale. You would have your own values based on the calculations that you did. Okay, so if I was to take a look at the value for copper, okay, the value for copper would be 0.385, I believe. Here, let me check. Copper is 0.385 joules per gram degree Celsius. So let's say those are the actual value, but when I calculated it, it ended up being like 0.45. Okay, so I would look at 0.45, which is right about here, and then 0.385, which is right about here, and then I would plot a dot right there, or plot a point right there, and I would do that for the other. So remember, the calculated is what you get in your calculation from your equation, and then the actual is what I give you, or what you were given in the lab. I'll go ahead and put that table up on here when I'm done talking about this lab, so you can write those values down if you don't already have it. Okay, and then, like I said, you would do the same thing again for iron. Let's say iron would cause you to plot right here, and then brass right here, and then the aluminum, say, right here. Okay, I'm telling you right now, these points are not at all accurate to what your real plot should look like. Okay, now from those 4, you draw a best fit line. Remember, a linear line that is showing that's representing all the data points as best possible. Okay, it usually does not go through any point in particular. Okay, well then with your unknown value, you're supposed to say I calculated it to be 0.25, which would be right about here, and I would look at the dot on or find it on the line with that y value, and then I would look down at the actual value to determine what my real value is, and then based on what number you get right here, and based on the table that I'm about to show you, you determine what your metal is. Now, if you have 2 metals that, it's like the value that you get right here is like right in the middle of two metals. Okay, you need to devise a plan to pick one or the other. Okay, I am going to look to make sure that if, if it's between, say, aluminum and calcium, or not aluminum, but calcium and potassium, if it's right in the middle of those two values, you have no basis to choose one over the other. Okay, so I mean, if it's closer to one than the other, then you got something. But if it's right in the middle between two values, then you need to devise some other plan or some other protocol to figure that out. Do you have to really do that? No, but you would just have to tell me that's what would be the next step. All right? And then, of course, the last thing is so 1 was the graph, 2 was the calculation, and 3 is I need 2 to 3 sentences. Okay, not 2/3 of a sentence. 3 sentences. Okay? Telling me what your unknown metal is, and then some justification of that choice. Okay, I'm going to show you the table real quick. Okay, so the metals that you had in your sample, or in your 4 knowns, right? You had aluminum, you had iron, you had copper, and you had brass. So these values that we have right here, okay, oops, no, not that one. This one, wow, I'm really off. This one, and this one. Okay, those 4, those are actually going to be plotted on your x-axis. Okay, you're determining the actual value of one of these 6 possibilities. Okay, one is potassium, another is calcium, another is nickel, zinc, tin, or lead. Okay, so based on your where where your calculated value intersects with the line, and then you look down on the x value to find, is it closer to 0.75, 0.65, 0.44, 0.39, 0.21, or 0.160. Okay, so you're going to choose one of those, and then, of course, give me 2 or 3 sentences justifying why you chose that. Okay, your other lab is actually going to be a full lab write-up. Okay, now the title of this lab is Determination of the Molar Enthalpy of the combustion of paraffin, which is the wax that you burn in the candle. Okay, now I'm going to go ahead and go over your Roman numerals. You have 1, all, 2, A and B, 3, all. Okay, those are your data tables. 4, none, because you don't really have a graph for this. Okay, let's see, 5, I want A and B. Now with B is supposed to be either the percent error or the percent yield. I want percent error. Okay, I want the percent error for this, for your molar enthalpy, whatever you calculated. Okay, I'm telling you right now, the molar enthalpy of paraffin, the actual molar enthalpy, the literature value, is, let's see, delta H of the combustion of paraffin is going to be equal to negative 14,816.34 kilojoules per mole, or kilojoules per mole of the reaction, right? If you don't remember how to calculate percent error, okay, look it up. Okay, it's also in past videos, but if you look up how to calculate percent error, it'll tell you. This right here, another way of saying this is the actual value. This is the theoretical value, right? This is what's supposed to, how it's supposed to come out to. All right. And then lastly, we have 6, right? Which is going to be A, B, C, D, and E. Okay. So this is your lab write-up, okay, everybody does their own. All right. Um, if you have any questions, by all means ask. The lab itself the due date will be discussed in class.